Welcome to Video Lesson 6, Chemical Properties. This video is going to introduce you to a few different topics, specifically elements, compounds, chemical change, chemical properties, and finally, the law of conservation of mass. Before we start, remember that your last video lessons introduced you to different kinds of matter, pure substances and mixtures, and discussed many different kinds of mixtures, as well as the idea of physical properties and physical changes. If you don't remember that video, stop, go back, and watch it first. If you do know what all of these words mean, you are ready to move on to chemical properties. Let's start with elements. First of all, what is an element? An element is a pure substance that cannot be separated into simpler substances by physical or chemical means. For example, oxygen gas, or sulfur, or aluminum. Elements are made up of a single type of atom, so no matter what you do to them, they cannot be broken down into a simpler substance. Where did the idea of elements come from? If you remember from earlier in class, alchemists tried to classify the matter around them, and as they did that, they kept coming up with new kinds of matter and naming them. For example, in the 1600s, an alchemist named Robert Boyle identified that some gases could be separated from air or from acid and metal. He showed that some substances could be broken down, while others could not. Other scientists, such as Henry Cavendish, later named these gases inflammable air and vital air, and showed that they could be combusted to form water. In the late 1700s, Antoine Lavoisier renamed these airs elements and called them hydrogen and oxygen. He went on to try to organize a list of elements known at the time, publishing it in one of the earliest textbooks of chemistry. Nearly 100 years later, in 1869, a Russian chemist named Dmitry Ivanovich Mendeleev created a periodic table that organized the known elements according to atomic mass and chemical properties. He organized his table into rows, called periods, and columns, called groups. This table, with additions, such as newly discovered elements, is still in use today. We'll study the periodic table in more detail later in class. Back to elements. Elements can be found as either monatomic elements or diatomic elements. Helium and neon are monatomic or monoatomic elements. They can be found as individual atoms. They do not have to be bonded to another atom. Oxygen and nitrogen are diatomic elements. They are often found as a pair of bonded atoms, represented by a subscript next to their chemical symbol. There are only 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, iodine, and bromine. There's an easy way to remember them. Never have fear of ice-cold bears. So let's review. Elements are pure substances that cannot be broken down. They can be monatomic or diatomic and are arranged according to atomic mass and chemical properties on the periodic table. Now that you know what an element is, let's look at elements in combination. A compound is a combination of 2 or more different elements that are chemically bonded. For example, water, H2O, is made of 2 atoms of hydrogen and 1 atom of oxygen. These atoms are connected by chemical bonds, which will be covered in more detail in later units. Notice that the compound, water, has 2 different elements. So this, a diatomic molecule of oxygen, is not a compound, but this, a molecule of water, is a compound. Compounds can be made or changed through chemical reactions. A chemical reaction is a process that involves one or more substances changing into new substances, The changes that occur are called chemical changes. More on these in a minute. In a chemical reaction, the substances involved are identified as either reactants, the substances that are present before the reaction, or products, the new substances that are formed as a result of the reaction. So, the reactants yield the products, which have different compositions and properties than were present in the reactants. Sometimes we can write a chemical reaction as a word equation. In a word equation, we use the names of the reactants and products, along with the symbols plus and yield, an arrow. This is the basic ingredient list for the reaction and does not include information about the amount of either reactants or products. Chemical equations are another way of writing chemical reactions and must be balanced. We'll cover those in a later lesson. For now, let's do an example. How would we write the word equation for the formation of water from hydrogen and oxygen? First, we should identify the reactants and products. Hydrogen and oxygen are the reactants. We write them separated by a plus sign to show that they will be reacting. Then we use the yield symbol to show that products will be formed. Lastly, we write the product, water. Here's another example for you to think about. How would you write the word equation for the reaction of iron and sulfur to form iron sulfide? As mentioned earlier, when a chemical reaction takes place, one or more reactants usually undergoes a chemical change. There are 4 main indications that a chemical reaction has occurred. The first is the formation of a gas. You will be able to observe this by the formation of bubbles from a liquid, or sometimes you may see the formation of a colored gas from reacting solids. Many gases are colorless, however, so this is not always easy to observe. The second indication of a chemical change is the release of energy. This can be observed in several different ways. For example, the reaction of phosphorus and oxygen produces bright light. Other reactions may release energy that can be observed as heat or sound. The third indication of a chemical change is the formation of a precipitate, a solid formed during reactions of liquids. For example, aqueous silver nitrate, which means silver nitrate is in a solution with water, reacts with potassium chloride solution to produce silver chloride, a white, solid precipitate. The fourth indication of a chemical change is a color change. This is not foolproof, but many chemical reactions do cause a change in color. Think of what happens to an apple when it is oxidized. The color changes from white or yellow to brown. These are all indications of a chemical change, but it is important to remember that the difference between a physical change and a chemical change is that a physical change does not change the chemical composition of a substance, while a chemical change does. Keep that in mind when determining whether a change is chemical or physical. Just like there were physical properties that were important in physical changes, there are also chemical properties. These properties are important when considering how a substance will react chemically. 5 common chemical properties are: 1. Flammability, or the ability to burn. Gasoline has a high flammability. 2. Reactivity describes if a substance is able to react easily with other substances, such as oxygen. 3. Fermentability, or the ability to ferment, is a chemical property that is extremely important for food chemists and brewers. 4. Corrosiveness is a measure of how damaging a substance is to other substances, including living things. Strong acids and strong bases are both corrosive. 5th is color change. An example of this would be the change in color that occurs in leaves during the fall. Notice it is color change, not color. Color is a physical property, or a description of the characteristics of the substance in its current state. To be a chemical property, the property must describe how a substance behaves during a change or a reaction. When considering chemical reactions, an important point to consider is the law of conservation of mass. The law of conservation of mass states that in an isolated system, mass is conserved. In other words, it is neither created nor destroyed by chemical or physical changes. In a chemical reaction, this means that the mass of the reactants must be equal to the mass of the products. Let's apply this to the reaction of hydrogen and oxygen to form water mentioned earlier. Hydrogen is a diatomic gas, as is oxygen, so we will write each chemical symbol with the subscript of 2. Water is going to be 2 hydrogens and 1 oxygen, so if we balance the equation, we get this. Looking at the periodic table, we find that the mass of hydrogen is 1 atomic mass unit, or U, while the mass of oxygen is 16 units. So, 4 hydrogen would be 4 units, plus 2 oxygens would be another 32 units, for a total of 36 units in the reactants. For the products, 2 times 2 hydrogens, or 4, plus 2 times oxygen, or 32, also adds up to 36 units. The masses of the products and reactants is the same, so this equation agrees with the law of conservation of mass. Try looking up a chemical equation. Does it agree with the law of conservation of mass? Let's review. You should have learned about elements and compounds, chemical reactions and chemical changes, the law of conservation of mass, and the history of the periodic table. That's all for this video.